All right, let's go ahead and look at example 1. The goal is to approximate the slope of the tangent line to the parabola at y equals x squared when we're looking at the point 1, 1. So the first thing I would do is confirm that 1, 1 is on my graph. If I plug in 1 to x squared, I get out 1. So I have my point 1, 1. And now what they're saying is we need to approximate what the tangent line is. So I did this a little bit earlier, but I would try and draw a tangent line. So I'm just touching at 1 point. So there's my tangent line drawn on there. I can tell it's positive. I would also notice that it looks steeper than a slope of 1. I'm not 100% sure what it is. Okay, so what we're going to do is we're going to keep our point of tangency stationary. Okay, so we're always going to be using the point 1, 1, and then we're going to go ahead and look at some secant lines. Okay, so we are going to use the secant line of when I plug in 0.5. Okay, so we got 0.5, so here and here. And then I would draw this tangent line, or sorry, not tangent line, to be a secant line, from my point of tangency through my secant line. And what our goal is to find the slope of this secant line. The way you guys find the slope is we would be using the 0.11, and then I would also be using the 0.5, whatever I get out. So in order to figure out my y value of this point, I take 0.5 and I plug it into x squared, because y equals x squared. So 0.5 squared gives me 0.25. Okay, so I'm using my point of tangency 1, 1, and then I'm also going to use my point 0.5, comma 0.25. Now from here, I will go ahead and find my slope using those 2 points. Y2 minus y1 all over x2 minus x1. Okay. So I would have, to find my slope, 0.25 minus 0.5, sorry, minus 1. 0.25 minus 1 all over 0.5 minus 1. So this gives me negative 0.75 divided by negative 0.5. And if you go ahead and do that on your calculator, you will get that it's a slope of 1.5. Okay. Now we're going to repeat. We're going to take that secant line. Okay. We won't be able to delete it, sorry. Maybe I'll delete my point. We're keeping the tangent line the same, okay, and we're still going to use the 0.11, but now we're going to go ahead and plug in 0.9. So I will go 0.9 here, and I'm going to find the slope of this line here. You guys notice as I move closer, it's getting a little closer to my tangent line. So in order to figure out my ordered pair I'm dealing with here, I take 0.9 and plug it into x squared. So 0.9 squared gives me 0.81. Then I would always use my tangent line point, so 1, 1, and 0.9, comma 0.81. Then I set up my slope, y2 minus y1. I'm going to start with my 1s first because I like to deal with positive numbers if I can. So it'd be 1 minus 0.81 all over 1 minus 0.9. When I type this in on my calculator and simplify, I get 1.9 as my slope. Okay, now we're going to move even closer to this 0.11. Okay, so I'm still going to be using the 0.11. But now I'm moving closer. I got 0.99. So in order to figure out my ordered pair here, I take 0.99, plug it into x squared, and this gives me 0.9801 when I square it. Okay, so I got 0.99, comma 0.9801. Sorry, that kind of is a little crowded there. And I would find the slope again with these 2 points. Okay, so I would give you guys a second. Why don't you pause it and find the slope of this one? Now that you've paused it and checked, you should be able to get a slope of 1.99. Now we're going to repeat this one more time. Okay, I'm taking and I'm going to find the point 0.999, so super duper close to 1 to figure out what I would get. So if I take 0.999 and I square it by plugging it into my function, I get 0.998001. Okay, this gives me an ordered pair, and I would still use my point of tangency, which is 1, 1. If I if I find my slope of these 2 points, you should get 1.999. Now, we are using the limits for the slope of the secant line. So what does that mean in order to find our tangent line? If I go ahead and look at the slopes of my secant line, if I look down this list here, what is happening to them if I were to guess if x was just equal to 1? Okay, and my y is 1. It looks like my slopes are getting close to 2. So that would be my approximation. So my limit as my x values are getting closer to 1 of my secant lines, it appears that they are equal to 2. So that would mean my slope of my tangent line would be 2. slope of tangent line equals 2. That's my approximation. And it actually is. We'll find out down the road how to find out exactly it is, but yeah, it is 2. Okay, so that's the slope of the tangent line. Just so you guys know, kind of coming down the pipeline eventually, slope of a tangent line, it's a big word in calculus. The slope of a tangent line is your derivative. Okay, a little terminology there. So slope of a tangent line, that's your derivative. And we'll figure out how to calculate derivatives as we go through chapter 2. Okay, so there is that. So this would be my left-hand side of my graph. Okay, so what do I mean by that? Do you guys see how all of these numbers are to the left of my point of tangency 1, 1? Okay, so I've checked it from my left-hand side. Now I should also check it from my right-hand side. So that's what we're going to continue to do on the next slide. Got to make sure that it works out from both sides. Okay. So we're doing the same thing. We just want to confirm that my secant lines appear to still approximate from the right-hand side a value for my tangent line of 2, okay, my slope of 2. So let's do this again. So we're always going to be using our tangent line. So we'd always be using the 0.11 for all of these. And then I'm just picking numbers that are to the right of my 0.11. So that would be 1.5. So we're going out further this way and we're going to check it. So if we plug 1.5 into whatever our function is given, I would get 2.25. So I have this ordered pair. Take 1, 1 in this ordered pair and I find my slope. Okay. So I got 2.25 minus 1 all over 1.5 minus 1. When you calculate this, you get a slope of 2.5. Then I'm going to take and move closer and closer to my tangent line, my point of tangency of 1, 1. So I would have 1.1. So if I do that, I have the 0.1.21. I'm going to give you guys a second. Why don't you pause and find the slope of the next 3, okay? Because you need to show your workout. How do you find the slope of the next 3? So go ahead and pause that. Now that you've paused, this should give me a slope of 2.1. This one, when I plug in 1.01 and square it, I get the 0.1.0201. So using this ordered pair and this ordered pair, I get a slope of 2.01. And then the last one, when I plug in 1.001 and I square it, I get 1.002001. So make sure you use the entire thing. And then you would find your slope, and it's 2.001. So same thing, as we are getting closer and closer to my point of tangency 1, 1, what does it appear my slope is getting closer to? 2. Okay, so my limit of my slopes of my secant lines would lead me to a slope of 2, and so then my approximate slope of my tangent line would be 2. Okay, and I've just confirmed it from the left and the right.